Hi, I'm Ben-Yaakov. This presentation is entitled Extra Diode to Reduce EMI. I'm showing here a DC to DC converter by diodes. This is a line interface type of a controller it's for 5-volt output. It's connected directly to the line. It will withstand up to 700 volt input voltage. The output is 5 volt, and of course it's not isolated. Now the internal circuitry of this controller is having here a MOSFET, that is a high voltage MOSFET, and then we have here a sense of the current, so it's actually limiting the peak value. So there is a controller here to limit the peak value of the pulse that will coming here. Actually, it's intended for discontinuous mode of operation. This is not the subject matter of this presentation, but this is just for general information. So this unit now is connected to the output network here. It's a classical buck network. The diode is here, so it's a non-synchronous buck. Output is here, and then we have the line connection to the line and a input filter for EMI reduction. So this is the connection of this particular DC to DC or buck converter. Now the connection of this converter to the line is via two diodes. Well, this is a unipolar rectification. This would mean that there is actually a DC component injected or drawn from the line. This is usually not acceptable and certainly not recommended. Now this unit, however, is of low power. So if it's low power, low current, you sort of can get by. And the same company, diodes, with another controller, which is for a higher current. This is for this one, and this is for the earlier one that I've just shown with the two diodes. And here for the high current, indeed they are showing a full wave rectifier. And in this case, of course, if it's balanced, there is no DC component. So here we have a DC component, and of course if this is a low power, then the DC value will be rather low. But the subject matter of this presentation is, why do we need this diode, this D2 diode? Okay, why are they showing this D2 diode? It would appear that without the diode, without this D2 diode that is just having a short here, just a connection of the line, everything will work perfectly okay. Because we have here, in this case, we have a AC component that goes like that. The DC part goes on through the filter into this unit. This unit now has some high frequency, which is sort of circulating here through this C sub 2, essentially. So there is really no need for this diode. It doesn't do anything. If it is replaced by just a short, then the functionality of this regulator will not be harmed. That is, if we just have here a connection, well, everything is okay. Everything seems to be fine. And then the question is, why do we like to have a diode here? And the reason is EMI. Now, we have to keep in mind that any system has some parasitic capacitances to ground. I'm talking about ground, not local ground, but actually earth, okay? And since we have this parasitic capacitance, I'm just showing it from this switching node to here, then we are going to have some RF high frequency component circulating in the unit. We have it coming from here through the capacitor, through the ground, and now if we have here a listen for measuring the EMI, then we have through this ground port the injection coming in here and then also in here. So we'll see a component here and here. So we have here both a common mode and differential mode components. So what is then the purpose of this diode and how can it help, if anything? And the point is that these diodes are not conducting all the time. If it is a low power and it is a unipolar rectification, the diodes are conducting only here. Most of the time, they are not conducting. So When they are not conducting, we have here capacitances. This is the capacitance of the diode because they are reverse biased. And if so, then the injection is really reduced pretty much. Now, without D2, like if I have here a short, then this injection is coming all the time because there is a path here throughout the AC cycle. However, if we have the diodes, then most of the time it's a low capacitance path, and only when we are at the peak here, there is a conduction here. So if you look at the average EMI, then obviously the average will be much lower than if you'd have here a short. So this is the purpose of adding this D2 diode. So this brings me to the end of this very short presentation. I hope you found it of interest. Thank you very much for your attention.